Homework 4.3, Properties of Logarithms, Video 6. Homework due Friday, May 29th, 11:59 p.m. The following video is associated with homework questions 14 through 19. In the previous video, we learned about the concept of expanding a logarithmic expression, the objective of which was to make the arguments as small as possible. Condensing logarithmic expressions is pretty much the reverse. The objective is to minimize the number of logarithms. Because you'll notice in the previous examples, we started with one logarithm with a big chunky argument, then we got lots of logarithms with as small as arguments as possible. Condensing is literally doing the opposite. You start with multiple logarithms with possibly small arguments, and your goal is to condense it into as few logs as possible, which usually is one, but the trade-off is the argument gets larger. So why would we want to condense? Because when we start solving logarithmic equations, which we will do in the next homework, one of the key moves is to minimize the number of logarithms in the equation, which we can achieve by condensing. Just a reminder, the benefit of expanding logarithms is to make calculus easier. The benefit of condensing logarithms is to make solving equations easier. So, how do we condense? Well, we just use these rules in reverse. In other words, from right to left. For example, let's say we want to condense log of 5x plus 6 minus log of x. We have the difference of two logarithms. And which rule involves the difference of two logarithms? The quotient rule. The quotient rule says if you have a difference of two logarithms, you can condense them into one logarithm. You just put the positive logs argument on top and the negative logs argument on bottom. So let's use the quotient rule. Again, this is, when you see this, it's so easy, it's almost ridiculous. If you have a difference of two logs, quotient rule says you can set up one log of a fraction. The positive logarithms argument goes on top. The positive logarithms argument is 5x plus 6. The negative logarithms argument goes on the bottom. The negative logarithms argument is x, so it goes on the bottom. If my goal is to minimize the number of logarithms, I'm done, because I have just one logarithm. That was quick. Don't cancel the x's. Do you remember why? In a fraction, you can only cancel parts of multiplication problems. The 5x on the top is part of an addition problem. You can't touch it. Now, if you want to be cute and say, well, can I split it into two fractions? You beat that into my head before. And then cancel, you could. So, is it better to say log of 5 plus 6 over x because I can split the fraction in two and then reduce it? You tell me. Did it meet our objective anymore by doing that move? Did we have fewer logs than we started with? No? Okay. So it's not a wrong move. I just don't think it's a necessary one. But I know if I didn't say, don't reduce the x's, some of you are going to say, I'm going to cross out the x's, and now I have 11. If you learn anything from me, please learn when you can and cannot cancel in a fraction. Let's take a look at the last one, which is a little chunkier than the first one. Which rule do you think we'll use to condense 4 log base b of x minus 3 log base b of y plus 2/3 log base b of z? Should we use the product rule? Should we use the quotient rule? Should we use the power rule? We'll look for evidence. To use the power rule in reverse, we need a log with a number in front. We have 3 of them. So I think we're going to use the power rule in reverse, which says take the coefficient, move it in, put it as a power on the argument. Are we going to use the quotient rule? I don't know. Do we have a subtraction problem? We do. So we'll use the quotient rule. Will we use the product rule? Is there an addition? There is. So we're going to use that also. So we're going to use all three of them, but which one should we do first? Well, as is, I can use neither the product or the quotient rules because those rules don't say anything about having numbers in front. So if there's a number in front, you can't do any of these rules yet. So we have to fix the fact that all three of these logs have numbers in front. So let's use the power rule. Not once, not twice, but 3 times. On the first logarithm, we can move the 4 inside as a power on its argument. So we get log base b of x to the 4th. On the second logarithm, we can move the 3 inside, but do we bring the negative with it? Well, that's really a subtraction, and we still need it between the 2 logs. So let's only move the 3 inside and get log base b of y to the 3rd power. And the same thing with the 2/3. So we'll have plus log base b of z to the 2/3 power. Now you might be thinking, oh, am I going to have to make a radical out of this? We'll talk about that at the end. But when you're condensing, you cannot condense if there are coefficients in front of the logarithms. So your first move, usually in condensing, is to move the powers back inside if there are powers to move inside. And now we have to decide whether to use the product or the quotient rule first. According to the order of operations, addition and subtraction do not take precedence with each other. They are usually done left to right. So let's try doing this left to right. The first operation is a subtraction, so let's use the quotient rule. In fact, I would have to use the quotient rule because if you try to use the product rule here, that first log is still negative. You can't just ignore that negative because it belongs to that log. That setup is not a setup for the product rule because the product rule makes no mention of having a minus in front of you. So we really should do this quotient rule first. So log base b, condense the first 2 into a single fraction because of the quotient rule. The positive logarithm's argument goes on top, so x to the 4th in the numerator. The negative logarithm's argument goes on the bottom, so y to the 3rd goes on the bottom. And the first 2 logarithms condense into log base b of x to the 4th over y to the 3rd. And we still have plus log base b of z to the 2/3 power. Again, we'll deal with the fraction power in a moment. But I want to finish condensing this because now it's just the sum of 2 logs, which means now we can use the product rule. And the product rule simply says, in reverse, the sum of 2 logs equals the log of the product of the arguments. The sum of 2 logs with the same base equals the log of the product of the 2 arguments. So I can condense these into one logarithm by simply multiplying the arguments. The first argument is x to the 4th over y to the 3rd. The second argument is z to the 2/3. I should really finish that multiplication problem. You never leave stuff unmultiplied. At the very least, you cram it together. And remember the rule for multiplying fractions. Tops get multiplied, bottoms get multiplied. The z to the 2/3 as a fraction is really z to the 2/3 over 1, which simply means when I multiply these together, the z will go on top. That's Amanda. Hi. Oh, you're fine. Thank you. Had a delivery, folks. Okay, so we could write this more cleanly as log base b of a single fraction with a y to the 3rd on the bottom, an x to the 4th on top, and I think now I'm going to go ahead and talk about the 2/3 power. I'm pretty sure the homework would accept z to the 2/3 power, but just for practice, what radical would that become? When you have a rational exponent, the denominator tells you the type of radical. Since it's 2/3, it would be a 3rd root. And the numerator of the fraction is still a power, so it would be the cube root of z squared. And that would be a good stopping point. I want to make one last comment before we wrap up this video. You can do long problems like this last one step at a time. And there's not a whole lot of them on your homework. There's only 5 of them. Excuse me, 6 of them. Silly me thinking that was 5 problems, it's 6. Count them out if you don't believe me. But if you do enough of these, you start recognizing that you can get to the answer almost instantly. But just asking yourself 2 questions. Question number 1, will the answer have a fraction in the argument? Yes, if there's a subtraction anywhere. So this one had a fraction, this one had a fraction because of that minus. And if there's a fraction, then it boils, the second question is who goes on which side with which powers? The powers are easy to spot, there's floating in front. But as far as who goes on the top and who goes on the bottom, it's easy. If your log was positive, you go on top. If your log was negative, you go on the bottom. Positive log, you went on top. So condensing can literally be done in one move. By first identifying whether or not you need to set up a fraction. That will be the case when there's a subtraction. And by the way, if there's not a subtraction, there is no fraction. You're just building a big multiplication problem. And then deciding who goes on top and who goes on bottom. So let me show you what looks like a hard problem, but it's ridiculously easy. Let's say I ask you to condense 19 natural log of A minus 20 natural log of B plus 25 natural log of C minus 1/3 natural log of D plus 1. Actually, this one isn't that hard. Question number 1. When we condense, do we need a fraction in the argument? Yes, because there is a minus, there's a subtraction. There's 2 of them, in fact. So, I already know that my final answer is going to be natural log of a fraction. Now I just have to go to each individual argument and really ask it 2 questions. What power will you get, and will you go on top or bottom? The A will pick up a 19th power. This is a positive logarithm, so it goes on the top. A to the 19th. The B will pick up a 20th power and go on the bottom because its log was negative. The C will pick up a 25th power and go on the top because its log is positive. The D plus 1 will pick up a 1/3 power and go on the bottom because the log was negative. Wait, 1/3 power, that's the same as a cube root. And it's over. So, and I'm not saying you might be able to do what I just did. It's not difficult. You just got to know the correct questions to ask and how to answer them. Again, the questions are, will the answer contain a fraction? If there's a subtraction, yes. Who goes on the top? The positive logs arguments with their respective powers. And who goes on the bottom? The negative logs arguments with their respective powers. So, piece of cake.